Hi.
So this is part 2 of the introduction. So Vachubai, you can carry on. Thank you, Anand.
Right.
Okay.
Yeah, please carry on.
Okay. Duplex of M will be say the M. We can say the base to 8, duplex of 3, duplex of 32, and duplex of 2. Means you start from either left or right, first digit, 2 digits. So one increasing and the increase over you are decrease. So this is 9. This will be 12. This will be 4. The unit says in 100. You can take it is a 4. These 2. And these 1. So you can take, in spite of this, suppose you are taking, I take directly to go to the bigger one. 1, 2, 4, 3 square. Suppose you have 4 digit number there. You can say duplex 1, duplex 12, duplex 1, 2, 4, duplex 1, 2, 4, 3, duplex 2, 4, 3, duplex 43, duplex 3. So what we have started? Either you start from here, go on the last digit, 2 digits, 3 digits, 4 digits, then go on decreasing 1 from line, 3 removing 124, 4 removing 12, 1. And so this will be 1, square is 1, this is 4, this is 8 and 4, 12, this is here 3 and this is 8, 11, double 22, this is 6, double 12 and 16, 28, this is 24, this is 9. And so it will be 9, 4, 0, 5, 4, 5 and 1. That's the answer. So once you understand what is the duplex, we directly start out these 3 in 9. 4 and 3, 12, double 24, correct 2. And here 6 double 12 and 2, 14, and this 16. To go on, the best way is we have to step forward and you can go one by one. So, and the carry will be added on the left, and that should be remembered. So, there is a way of using the duplex. Well, let us go to algebra. We shall discuss some 2 or 3 topics on these, and then we shall go to even jump also. One is, suppose you want to multiply 3x plus 4 into 2x plus 7. So you can understand this. We go back to arithmetic. 4, 7 is 28. Crisscross method is 21 and 8, 29. So 29x. And we go this one is 6x squared. So if you remember the crisscross method, easily you can write a product. I take you the bigger one and 4x squared, 2x plus 3 multiply by 2x squared, 5x plus 7. When it is negative, you can subtract it. Do remember. So if you start from here, 4 into it is 8, x 4. So here is a 20 and the 4, 24, 24x cubed. Take this one, this is 28 and 6, 34 and 10, 44 x squared. Then we can go here, 14 and 15, 29 x, and this one. Using the crisscross method, you can directly write down the product that it may be bigger or no problem. Just understand x squared is x fourth, x cubed, x squared, x and constant. And so on you say 4 to the 8. This is 20 and this 24. This is 28, 34 and 10, 44. Then this is 14 and this is 15, 29, 21. So you can directly write down the product that two. Maybe it's easier. Well, and there are many things here. I shall show some simple technique. See, suppose I want to solve it. 3x plus 4 or 9x plus 8 is equal to 4x plus 3 and 8x plus 9. The method is known as Sunyam Samnam Samuchaye. This way we shall see. Go on adding, you are getting. See here. This is 12x plus 12. Here also 12x plus 12. You can see both are same. You can get is equal to 0, x is equal to minus 1 is the answer. Without solving directly, you can get the answer. Same way, you can say if we add this way, you can go 4 and 3, 7, and this 7, x plus 1. And same way here also, 17 to x plus 1. So these also will be 0 to the x minus 1. So without cross multiplying, transferring, you can find out the answer. Same way, I take you, see, I'm only trying to show you the method. I don't go in details at all. You can say, this is x plus 2 upon x plus 3 plus x3 upon x plus 2 is equal to 17 upon 6. You know, you have to take LCM, cross multiply, simplify. Okay. So you can say, if you understand, the 3 by 2 plus 2 by 3, I will solve, it should be 13. The method is, you can say it is, this is 9 plus 4 upon 6 to get these two. And so you can say that x plus 2 upon x plus 3, 3 upon 2, or x plus 2 upon x plus 3 is equal to upon 3. Now if you know invert end also, take it inverse. It will be that x plus 3 by x plus 2, which is 2 by 3, or x plus 3 by x plus 2, 3 by 2. Okay.
I am totally lost. What are you trying to do?
So what you need is, if you can convert this into 3 by 2 and 2 by 3, these are inverses. This way with this, or this way with this one. So if you can observe it, you can very easily say either this or this. And you then either cross multiply or dividend method is also there, whatever you like. The best is you can this order also. These 3x and these 2x, 3x. This is 9 and this is 4, sorry, minus 5. Same way here, this is 3x and this is 2x, so it will be x. This 6, these are 6. That's it. So you can cross multiply and find the answer. So, or simply there is a division method that actually is going detail. This also way you cross multiply 3x, 2x, transfer it back at x. This is 9 and 4 and 5 and so on.
Okay.
Well, I should take you to 3x cubed minus 7x squared plus 4x minus 4 and here by x minus 2.
Okay.
So you can say put a 3 minus 7, 4 minus 4. The coefficient in descending order. Because the z has to be 0, you can put up x equal to 2 here. Start with 0, this addition. This into this, it will be 6 minus 1. This into this, minus 2, it is 2. This into this, it is 4. So remainder is 0. You can say that 3x cubed minus 7x squared plus 4x minus 4 is x minus 2. 1 less, it is 3x squared minus x plus 2. Well, so this is the way how to step forward and how to find out the division. This also, then there is a remainder method.
Sorry, I am completely lost.
Okay.
So could you explain that again? What?
Sure. Why not? Okay. See now, put the coefficient in order.
Right.
The descending order essentially
Okay.
is 3.
Right.
Minus 7.
Yeah, I understood that. Yeah.
Because these are 0, we are
Right.
getting x equal to 2. Put it here.
Oh, it's a root of the divisor. Okay.
Yeah.
Okay.
Then you put 0, start with 0.
Okay.
Add this to 3.
Okay.
2 into 3, 6.
I see.
Add him, you are getting minus 1.
All right.
Multiply these 2, you are getting minus 2.
Mm-hmm.
Add them, you are getting 2.
All right.
Multiply these 2, you are getting 4. This 0.
Okay.
Supposing for, in spite of that, suppose there will be 7 here. You can put it 7. You can say minus 3. And these are remainder. You can say minus 3. If it becomes 0, it's a factor.
Mehul, are you saying something?
Yeah, if it was divided by x plus 2.
Yeah. So we divided by x minus 2, constant this one.
No, suppose it was divided by x plus 2.
The different example x plus 2 divided by x plus 2 you are asking, right?
Okay.
Yeah.
Okay.
Three minus 7, 4 and minus 7. Okay. And minus 2 will be here.
Right.
So it will be 0 here. Okay, 3. This will be minus 6. Minus 13. These two product will be 26. it is 30. And this will be minus 60 minus 67. And so you can say 3x cubed minus 7x squared plus 4x minus 7 is x plus 2 into 3x squared minus 13x plus 30 minus 67.
You understood, Neville?
Yeah, I was just wondering, why do you change the sign of the divisor?
It's a root of the divisor. X
Root, yeah, here.
x plus 2 equal to
X
0.
plus
If you
2
put
equal to 0. That will give you x to the minus 2.
Okay. All right.
Okay. And this will be used especially in the remainder type of factors. How to find the factor, I don't take it in deep. But what I wanted to show you, there is also a method of division by one and one number with another one. Okay. Well, let us go to geometry even. There is a modern triplet. So, condition is this one, that our Indian saint Buddha was there and he was working in geometry and he was working with a rectangle. If you want to find out, this one is A, this one is B, and this will be automatically 90 degrees, so it will be A square or B square square root. He put up a verse and he crashes this one. What happened is, I already tried to take you to history that this is known as the Pythagoras one. This will be C, we say is A square plus B square is equal to C square. And instead proved it that Buddha find out this principle 500 before Pythagoras. We shall not go in this at all. We are interested how this can be used now. Question is this one. Let us see how this Buddha and triplet can be useful. Well, I take you to play. You can say, suppose M is an odd integer. So n minus 1 by 2, n plus 1 by 2. So this will be a Buddha triplet. So I take you, suppose n is 3. Okay, I'm sorry, n square. So it is 9 minus 1, 8 is 4, 5. Well, I take 5, 25 minus 1, 24, 12, 13. Take 7, 49, 48, 24, 25. You can take 9, 40, 41. And you can write down now. Try to get it 11 and 13. Can you try? If you succeed, it is 60, 61.
61, yes.
This is 64, 65.
Right.
Okay. Well, the second one will be 2n, n square minus 1, n square plus 1. This is also a Boolean triplet. Question is, do you remember Boolean triplet defined this way? If a square plus b square is equal to c square, ABC is a Boolean triplet. You can see n square minus 1 square plus 2n square. So it is n4 minus 2n square. 4n square is plus n square. Very easily it can be written. And so you can say now, suppose it is, see now, suppose n equal to 2. So it is 4, 3, then 5. Okay. N equal to 3, 6, then it will be 8 and 10. Well, I can easily say that if this ABC is the Boolean triplet, then K, KB, KC also a Boolean triplet.
Right.
You multiply this by K
K
square
square.
A square, K square B square, is K square C square. Okay. So it is K, KB and KC. You can see 3, 4, 5 was our Boolean triplet, 6. Okay. N equal to 4 is 8, 15, 17. Can you find out N equal to 5?
Yeah. And
Okay. Can you take N equal to 7 and count out?
40, 48.
14, 48. These are another form of 7, 24, 25. So I think you can find out many more. Well, now I take you and third one is 2AB and B square plus B square. If Boolean triplet is greater than B, should we remember? Okay. I think A is equal to 2, B is equal to 3, this will be 12, this 5 and 13. A is equal to 3, B is equal to 5. Oh, I'm sorry. A is equal to 5, B is equal to 3 and B equal to 2. Should remember A is to be greater than. So you can say 30, 13, 27, 34.
It's okay.
30 and 30 is 25 minus is 9. Sorry, I'm sorry. Should be 16 now. 25 minus 9, 34. 8, 15, 17 there.
Right.
So you can find out many more.
Right.
What I am interested in,
Right.
how this will useful to the student level. See,
This is good.
useful to students without calculating much. Suppose here, for example, this is a right angle triangle. Okay. Is 2.1, 2.8. What is this much? No doubt, 2.8 square plus 2.1 square, add it and find the square root. I take it to playway method. You can say, make the circle. You can say, make the circle means these decimals are abolished. Then it is these 3, these 4. You can say these 5. We know 3, 4, 5 is the Bose-Einstein triplet.
Right.
3 7s are 21. 3.5 is the answer. Nothing more you need.
I see.
Okay. Well, see the way. I shall take another way. Right angle triangle. Suppose this is a question to find out. Not you can say 17.5 square minus 4, 9 square, and so on. You can take, circle it.
7 times.
This 7, 25.
Right.
This will 24.
Right. So it's 7 times 24.
See the answer.
Right.
Can
Simple,
you
very simple. If you know,
can you write the formula on the whiteboard?
excuse me.
Can you write the formula on the whiteboard?
A square plus b square equal to c square of ka square plus kb square kc square.
So how did you do 17.5 minus 4.9?
Oh, no, not so. See, we remove the decimal point. We see that 7 is a common. So you can say this is 7 into 2.5 or 0.7 into 25. And this is 49 is 7 into 0.7. So 0.7 is common k. So now it is 7, 25. So this is 24. Now we come back 24 into 0.7.
Because 7, 24 and 25 are Bose-Einstein triplet. So we find a factor Bose-Einstein triplet.
Yeah, I got it. Okay, I got it. Yeah. So basically, the thing is you factor out, and I think you can use algebra out here also, right? The previous one where you factored out a more complicated equation into two smaller things. Okay.
Yeah.
Oh, he's saying that can we use the factorization which we did, like x dividing by x plus 2 kind of thing, and this to do. So can we do factorization also using Vedic mathematics?
Oh, Vedic factorization, there are, you need a time.
Okay.
You can even do the popular method is algebra. There are there, but in spite of that, we know it x square plus 3x minus 28. So generally we know that factor of this one 7 into 4, and the subtraction is 3. You can directly factor. But main thing is you can start in the Vedic method start this way. You can say therefore you need 28 and difference is 3. So 1 4 4, you 2 4, you can go and calculate the difference is 2 3, 2 5 10, and 3 3 6 18, and you can say 4 7 28. So he said he starts from here Difference is 3. You see difference is 3. So you can say 1, 4, 2, 5, then 3, 6, 4, 7, and product is 28. So 4, 7 as a proper pair. So different methods are also there for factorization. There are some methods which you can apply or also. But NAD is also now a general method is there, and that is a perfect square difference for a trinomial. Therefore, you can convert it into perfect square by multiplication and division. You can get also, but I think it takes some time. So I don't discuss it here. Otherwise, you can do. Well, I shall take you to one more extension. This is one thing I wanted to draw attention that the Bosanian triplet can be helpful for finding the solution of a right angle triangle. The two sides are even, so it can be obtained very easily. Okay. Well, I take you to one. Okay, you can say mounted extension or a function also, and that we know. In fact, what I want to draw attention is even this is not in the Swamiji's book, but I shall try to draw attention that if somebody had gone through the book of Swamiji, in many chapters he has written that we shall discuss it onward. Everywhere he puts the word. At the end of the chapter, he will say, we shall discuss it onward. Or discussing any method, he can say, we shall do this on, but we shall discuss onward. Unlike what Swamiji died before time due to sickness, and we lost him. In fact, it becomes our duty to find out the way in which he has showed you the way. Go the way. According to me, Vedic mathematics is not only the things which are only described in the Swamiji book, but it is our duty. The way, what he has showed you see the way I showed you. The simple way. How you can use the Bosanian triplet. Once you know the Bosanian triplet, you can find out the solution of a right angle triangle without more calculation. Even and nowadays we know that there are options given. If one option is to be selected, this becomes, I think, very much helpful. Okay. Well, I take it this way. This is 1. This is 1 and 1. You considering both are 0. Consider both are 0, 1 to 1. Consider both are 0. This is 1, 3, 3, 1. Consider both are 0. Is 1. Is 4, 6, 4, 1. Consider both are 0. You can say 1, 5, 10, 10, 5, and so on. You can go. Even one more. 1, 6, 15, 20. This is 15. This is 6, and this one. Now, question is, can you write down for n equal to 7? This is n equal to 6. Or n directly without taking this one. Can you write down n equal to 8? Now, this is a question. So, you can develop it more. Or I shall take back. See now, you want n equal to 8. Okay, write down 8, 7, 6, 5, 4, 3, 21. Okay. Now we start with this one. 1. Then I put it 1 here. 1 into 8. 1, it is 8. What I done? One term left. Okay. Now 8 into 7, 1 and 2, by 2, 8. Then 28 into 6, by 3, 56. 56 into 5 by 4, 70. 70 into 4 by 5, 56. 56 into 3 by 6, 28. 28 into 2 by 7, 8. And 1. You can see. This is a playway method. What we do is, we want to write down n equal to 8. So write down in the descending order. Put 1, go on multiply, and many terms are passed out to your byte. 1, 8, 1 term is left. 1. 8, 7, 2 terms left. 28. 28, 6, 3 terms. 4 divided by 6. We are getting. So now it's over. Now question is now how will you use of this? So you can say this gives you 1 plus x raised to 8. You can start 1 plus 8x, 28x square, 56x cube, plus 20x 4, plus 56, x is to 5, plus 28 x is to 6, plus 8, x to 7, plus x is to 8. So what you need is, you want the expansion of 1 plus x is to 8. Here are the coefficient obtained. You start with 1, x, x squared, x cube, plus x 8. Are you clear?
Yeah, in fact, my observation is it is also the same as
NCR.
NCR.
Yeah, it is.
So, when you have n times
N into n minus 1 by 2
times n minus 2 up to
3.
So then 3
Yeah,
would be
and so on.
this one. And
Yeah,
so that means I was trying to understand what does this Montaigne extension do? Is it only for the finding out 1 plus x to raise to n, or does
yeah,
it
no, I'm good.
more?
Okay, I'm good. Play. Now question is, see here. Okay. I shall take you now. I done 1 plus x is to 8. And here 1, 8, 28, 56, 70, 56, 28, 18, 1. Okay. Can you find out 12 cube or 12 is to 8?
Oh, I see. Because you know 11.
Yeah.
Right.
So now this is how we are told. So you can say 1, 2, 4, 8, 16, 32, 64, 128, and 256. With the powers of 2. Okay. Multiply these two. You will get in 1, 16, 112. It will be this, and so on. Take the unit digit, the remaining part adding on the left. So it's a big number here. 1 plus x is to 8 is a big number. 12 is to 8 is a big number. But instead of this, suppose small powers are to be obtained, small number, 12 is to 5, it becomes very easy by this pattern. What I want to draw attention is this Montaigne extension will be helpful. In fact, I take you back.
So you did 12 as 1 plus 2?
No, 12 is 10 plus 2.
I thought you might do 1 plus 11.
Mm-hmm.
I thought you would do 1 plus 11 raised to 8.
Oh, 1 plus 11.
Raised.
No, but I should say, base should be remembered, no? If you take 1, the 11 base will be there. in spite of what we are doing is 10 plus 2. So you are taking x equal to 10, and so only in the power there will be only zeros. So in spite of 1 plus 11, for us is 10 plus 2.
Oh, okay. So then x is 2, and then you get the big number, and then you add 1 0 at the end, or you add eight zeros
So,
at the end.
as I understood, I mean, I am also confused, but let me understand this. You started with 1 plus x raised to 8, right? So you had coefficient 1, 8, 28, 56, 17, 56, 28, 8, 1. Now,
Let us take 4 power.
right.
Yeah,
Right, so when you take 12, you take
10 plus 2.
10 plus 2, then you basically for 2 you are finding the coefficient, right?
Yeah. So what I say
So
is,
what he's doing is,
yeah,
he is going one step further because it's not 1 only, it's 2. So he is making, 2 say
2 plus 10.
2 plus. So whatever he's getting with that is corresponding to 2.
I got it. Actually, it would be good. What you can do is you can divide the whiteboard next time into 2. On the left hand side, you keep the formula on. And
Right.
then on the right hand side, you take the examples. But it's okay. And so, but then you add 8 zeros at the end, right?
Yeah.
You add 1 0 or 8 zeros at the end.
No, then it's a matter of just writing the coefficient, because this, by virtue of like you picking the 10, your 10 raised to 8 will become the 8th digit.
Oh, I can see what it is.
Can you repeat? Can you repeat
Just
that?
a minute.
Can you repeat that 12?
Okay.
12 raised to 8. Can you one more time? Can you do that 12 raised to 8?
Shall we take another one?
Yeah, the focus has gone low again.
I see.
But that's okay. I think it's trying to focus in and out.
All right.
Maybe you can take the laptop to the whiteboard.
Okay.
Is it better? Can I drop out and drop in again?
Yeah, you can drop out and drop in again.
All right. Good. So let me do that.
So we're going to wait 1 minute. They're going to join again.
Is it better?
Yeah, it's better.
Right. Probably the quality goes bad after some time.
Okay.
All right. So I think, yeah, please be free to give us all the treasures, anything you want.
That's all. Yeah.
Okay, so yeah, just to finish up, can you take the example of 12 raised to 4?
12 raised to 4.
Nice.
Yeah, that's probably what he wanted to do.
We take 13 raised to 4.
Yeah.
Okay. Well, we know n is equal to 4, 1, 4, 3, 2, 1. So it will be 4, 6, 4, and 1. 1 for the 4, 4 to the 12 by 2 is 6, 12 by 3 is 4, and this one. Okay. Now we need, see, this is 3. So it is, you can start at 1, 3, 9, 27, 81.
That 1 on the second line should be 2, the last one. I think that should be 2, right? It's 4 divided by 2. The last one.
Okay, see now, 1 into 4 by 1 is what? 4. 4 into 3, 12 by 2 is 6. Secret 12 by 3 is 4, and 4 1 4 by 4 is 1.
Okay.
Okay? Well, so this is 1, this is 12, this is 54, 108, 81. 30 to 4. So you can say 1, 6, 5, 8 into the answer. 1, 8 added here, 16, 11 and 4, 15, 1, 6 into 8, 1, 1, 2. Is it?
It's clear. So this is like 13 4, right? So up to 1, start with 1, then 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, and then this
Product.
Yeah, no, I understood that part where it did 10 plus 3 raised to 4, right? 10 plus 3.
Yeah. It is 10 plus 3 is to 4.
Okay, so I'm saying, where do you put that 0 in there?
1, 2, 3 and 4 zeros is 10 is to 4. You can see 1, 1, 2, 3 and 4 zeros. Here 1, 2 and 3 zeros. So this is 10 is to 4, 10 is to 3, 10 is to 2, 10 is to 1 and 10 is to 0.
so
And then how did you get that 1, 2, 5, 4?
Oh, just I want to draw attention. Say, suppose I want to use this one. 1, 0, 3 is to 4. The same can be used. You should remember there are 100 base. So 2 digits everywhere you have to put it up.
right.
And
Yeah.
so now I remove this one. And see here, this is 1, this is 12, this is 54, 108,
Right.
81.
Right.
And so it is 1880 55 12 and 1 is the answer.
Right. Very nice.
Did you follow it?
Kind of. I just wanted to know, how did you get the third line, the fourth line? 1, 2, 5, 4, 10, 8, 8, 1. Yeah, that line.
This line, right? This is product.
Yeah.
So this is 1 times 1 1.
Okay.
4 times 3 12, which is 1 is remainder.
Oh, I see. Okay.
Yeah, it is.
By the way, this is my observation. What you are doing here is basically you are breaking in terms of 10 plus x
Yeah,
raised to 4.
Correct.
So you have basically 10, 4, and the coefficient, then 4 times 10,
Into 3.
10, 3x, 10x square, 10x, and then x. And here you have 4, 6, 4,
3.
1, 1, right? So what he's doing is he's finding this first, and then he's finding this
Yeah.
3, 4.
It's the power of the 10.
So this is this, and this is this, and then he's multiplying because this is multiplication, and then putting on the appropriate place like 10 digits of 10.
Okay. No, I think I think we got it. So are we done now? It's like
Yeah.
you know,
So
you know,
can we have another good one and wrap it up? Anything else you want to have?
Well, yeah, I want now, at the end, the last topic I want to discuss is this one thing. And I take you, going to, if ABC is a Boolean triplet, you know, KA, KB, KC also is a Boolean triplet. And same way you can say that A by C, B by C involves a Boolean triplet.
Right.
Obviously, this will turn to this is cos theta, this will is sin theta. So now question is this one. is, now this is A by C, B by C, and this is 1. So if you Boolean triplet, you are divided by this one, you are getting cos theta and sin theta. Now you can say this is, you can say theta. You can say if theta is A, B, and C, then 90 minus theta will be A and C. If you divide by 1, you have by say, so you can say this is alpha. Same way, now you go on developing it, you can say, see, even more work can be done. Then we know this is A, this is B, and this is C, or this you can say H. No problem. This is A by H, B by H. This will be 1. Now this will be cos theta, and this will be sin theta. Now, question is, see, if you have, say, you can say, can you tell about the 30-degree or 60-degree or 45-degree? You know, you can find out. This is 30. We know if this is 1, this will be 2. This will be 3. So it will be root 3, 1, 2. And this will be 1 root 3, 2. If it is 45, 1, 1, and this will be root 2. So 1, 1, 2 will be there. And now, so if you divide by 2, you can say it is nothing but it is root 3 by 2, 1 by 2, and 1. This is 1 by 2, root 3 by 2 is 1. This will be 1 upon root 2, 1 upon root 2, and 1.
Are you going to confirm this with the Bodleian triplets? Are you going to confirm this answer with the Bodleian triplet formula, that n squared 2 n minus 1?
Yeah. Can you repeat it?
Can you confirm this answer, root 3, 1 and 2, with the Bodleian triplet formula, the n squared 2n minus 1? Remember the one you taught us half an hour back? Can you confirm this with that?
1 upon 4 is 1.
Huh?
Is 3 upon 4. 1 upon 4, it will be 1. 1 upon 4, 3 upon 4, 1. 1 upon 2 plus 1 upon 2 is 1.
Okay.
Is it? Okay. Well, and now see here. Is alpha is A, B, and 1. Beta is, or you can say A1, B1, C1, no problem. This will be
went out of focus again.
Oh, let me do something.
It's okay. You can just you can drop off and join in again, and then we'll finish it soon now.
Right. Is it any better?
No, it's not. No, it's not. It's the same problem.
All right. Okay. Yeah. So.
I can say. See, you can grab forward even last. Because A, this is B, and this is H. You can take it here, H. This is theta. This will be theta by 2, we know. And so, now you can go forward, you can find out is a plus h squared b squared, which is c, and this is squared. This is a squared plus 2ah plus h squared plus b squared. And we know that a plus b squared, that will be h squared, 2h squared plus 2ah, and so it is 2h into h plus a. And so it is, if theta is equal to ABC, then theta by 2 will be equal to, you can say, is a plus h. This is b. This is 2h into h. Then, and similarly we can go forward. And we can extend it even. We can find out alpha plus beta and alpha minus beta. The formula also can be found out. This is a way you can extend it. And by the way, trigonometry can extend it, and you can get the formula in these steps. Okay.
Thank you very much. Thank you very much.
Thank you. Thanks a lot.
Yeah, thank you very much, Bachu-bhai. We appreciate it. So we will stop the
to put up the idea of what is the trigonometry, what is the Vedic mathematics. In fact, Vedic mathematics, according to me, is an idea of thinking how to make it simple to understand by others.
And how to use the what you just learned.
Yeah, obviously.
In an iterative manner.
Thank you very much.
Almost like computer.
It is almost like intuitive mathematics, right? Intuitive mathematics.
Intuitive, iterative, yeah.
Yeah, it is true.
Right.
People will intuitive to think more.
And then we have to carry forward that Swamiji's ideas and make new.
Yeah, it will be done.
Actually, I really have to say this. So on the car, in the car, he said that he actually completed one of the verse. Actually, extended one of the verse. Could you?
Yeah. If you had gone through book, Yavadunam, Tavadunikrutya, Vargam Chayoje, these are the verses for finding out the square of a number. We had framed a new verse, Yavadunam, Tavad, Trivaram Unikrutya, Trivaram Vargam Cha, Ganam Yoje, is for Q. So such work should be done, and we should try for it. I repeat it. Original formula for the square is Yavadunam Tavadunikrutya Vargam Chayoje. We have framed a verse for Q. Yavadunam Tavad Divaram Unikrutya Divaram Vargam Cha Ganam Yoje, and that gives the curve. But I shall give you the book.
Yes, thank you very much. Thank you.